Number 72, verify that after a time of 10 milliseconds, the current for the situation considered in example 23.9 will be 0.183 amps as stated. So first, if you read letter A here of example 23.9, it says it's asking us for the time constant, all right? When we have this 7.5 millihenry inductor and this resistor, we know how to solve for the time constant now. It's just the inductance divided by the resistance. The time constant here will be the inductance 7.5 millihenry, but you know we need that in henry, so therefore we're going to multiply by 10 to the minus 3. The resistance there is 3 ohms. We don't have to do anything to that. And then what we're going to do is we're going to take out that calculator and we're going to start plugging some numbers in. So it's 7.5 times 10 to the minus 3 divided by 3. And this works out to be about 2.5 times 10 to the now minus 3. All right, seconds. So 1, 2, 3, yeah. So that is now the time constant. Now what we can do here is we can now use, all right, the basically the decay formula here. Okay, this is a type of exponential decay, and where we can find now that the current at some future point in time will equal the initial current, okay, I sub O, so I'm going to call it I sub I for initial, multiplied by e raised to the negative t divided by tau. So this is the time that the circuit's on, this is the time constant, and this is the initial current. So the initial current here, it told us in the problem, is 10 amps. So plug that in. Then the time, well, how long? It says verify that after a time of 10 milliseconds. So we know that this is going to be 10 times 10 to the minus 3. Then divided then by the time constant, right, which we just found, which is 2.5 times 10 to the minus 3. So these basically will cancel out, and then you can take 10 and divide it by 2.5, and then works out to be about 4. And don't forget the negative sign there as well. All right, so this is going to be now the current at some time in the future, basically 10 milliseconds, is going to be equal to 10 raised, 10 multiplied by e raised to the negative 4th. So simply take out now the calculator and do 10 multiplied by e raised to the negative 4th. And we get a value of 0.183 amps. Wait a minute, that's what the problem told us. That's the point. Guys, thanks for tuning in. Appreciate it. Hopefully that helps. And check out some more of the videos if you're taking chemistry or pre-calculus concurrently or sometime in the future. Or if you could time travel sometime in the past. Check out some more of our videos. All right, we solve basically all the OpenStax books. Even if you're not using the OpenStax book, you can download it for free, and the problems you have in your other textbook are basically identical to those in the OpenStax book. So find stuff that looks identical or very, very similar, and you'll know how to go about and solve those problems. Guys, again, thanks, and I'll see you soon.